today's lesson, the fundamental theorem of algebra. Our learning targets: know and apply the fundamental theorem of algebra and write polynomial functions given their degree and roots. Alright, so as a consequence of the fundamental theorem of algebra, a polynomial p of x of degree n greater than or equal to 0 has exactly n linear factors. Counting factors used more than once. So essentially what this is telling us is that we can use the degree of the polynomial to figure out how many roots there are. And that can be a combination of real roots and imaginary roots. So they could all be real, they could all be imaginary, or a combination of both. But if it's a x squared, that means the highest degree is 2, so there's 2 roots. If it is a cubed, highest degree of 3, then it's going to have 3 roots. If it has, a highest degree of 10, then it's going to have 10 roots. They may not all be real, they may not all be imaginary, but together there's 10. Right? So that's really all that's saying. So here in example 8 says find the zeros. We have f of x equals 3x cubed plus 2x squared plus 6x plus 4. Show that the fundamental theorem of algebra is true for this function by counting the number of zeros. So looking at the polynomial here, with the highest power, 3, so how many roots does it have? 3. So we're going to go through and we're going to set it equal to 0. So we're going to make sure everything's on the same side. And then we're going to factor by grouping. So we're going to take these first 2 terms and group them together, and these second 2 terms, group them together. We're choosing grouping because there's 4 terms, and it's really our best bet. Can't take out a common factor from all 4 of them. So I can see that these 2 have an x squared in common, and these 2 are both even. So we'll group them together, see what happens. Oh, no. Well, let's go with my thought process. So 3x cubed, so if we group these together, they both have an x squared, right? So that gives us 3x plus 2. Then what about these 2? What do they have in common? They have a 2, so we can take out a 2, and that gives us 3x plus 2, right? They're doing it differently, but are we going to get to the same thing? So then what do I have in common here? I have 3x plus 2, so I can pull that out. And then what's left from this one? When I take out the 3x plus 2, what's left? X squared plus 2. And that equals 0. Alright, so from here to here, even though I chose a different path, did I get the same thing? Yep. Alright, so then, now looking here, so we're expecting 3 roots. I have 3x plus 2. I can set that equal to 0, right, and find. And then I have x squared plus 1. So this, I can find the value of how many x's. 1, because I have x to the 1 power, right? And then x squared plus 2, that's going to give me 2, right? So it's x squared. So then, down in step 5, we have our 3x plus 2 equals 0. Solving for x, we get x equals negative 2 plus 3. And then we have x squared plus 2 equals 0. Moving the 2 over here, and this is the step that they skip. They have x squared equals negative 2. And then to undo the square, we square root both sides. We have the square root of negative 2. When you square root of negative number, that's I, it's your imaginary. So that's where that x equals, and you always have a plus or minus. I square root of 2. So that kind of skipped that part where they square root. So those are our 3 roots. Since this is plus or minus, that's 2 roots, and then our 1 root here. So with this one, we have 1 real root and 2 imaginary. But it gives us a total of 3 total roots. So not too bad, right? All right, so let's do a practice. Which one do you want to do together? A through F. The first one? All right. So we have x cubed plus 9x. Can we take out any greatest common factors first? Yes. What can we take out? We can take out an x. So let's do the x first. So then we have x squared plus 3. All right. So I have my function equals x times x squared plus 3. So this, I can set that equal to 0, right? And then I can set this equal to 0. So what do I know about one of my roots right away? One of my roots is going to be 0. That's a real root, correct? I know sometimes we don't like it when things equal 0, but that's perfectly okay. And then we're going to set this, the x squared plus 3 equal to 0. And we're going to solve. So we need to get x by itself. So we need to move that 3 to the right of the equal sign. How do we undo a square? A square root, but when we square root, we have to do both sides. So when we square root a square, what are we left with? X. And then over here we have the square root of -3. When we square root, how many answers do we get? 2. We get a plus and a minus. And then to deal with the negative, we put a I. So we have 3 roots. We have x equals 0 as one root. And then here we have our plus and our minus. I times the square root of 3, so that's our total of 3 roots. So our 3 roots are x equals 0. And then plus or minus I squared root of 3. Alright, so let's do let you do E. That's a grouping one, so it'll be real similar to the example A. Do E, and then we'll look at some of the other ones.
I don't want to do it.
Alright.
I'm too busy playing with my chest.
The internet didn't want to know that.
They can tell.
Okay, which color should I use?
Red.
Do you want me to write up there?
Wow, right. So can they hear us right now?
Kind of. I have the microphone on my laptop. Oops. Okay, that's fine. I always like square things. So you can really tell when I turn. You turn towards the laptop, I get really loud.
Just like take it.
Well, it's just my microphone. It's not working. I had a new battery, but it's still working. I just need to get one that has like the USB port, so it doesn't need a battery. I hate this board.
Kate.
put plus or minus for these two, right? No, one's just gonna be minus. Okay. That's one answer. Yeah, we can move that.
Yeah. There you go.
How come you can't like write? We can even take it one step further. What's the square root of 9? 3. Plus or minus 3i, and then x equals -5, and then 3. 3. Alright, so are we comfortable with that? And that kind of helps to kind of refresh the. It'll be the class mascot for today.
You will never have a ball.
All right.
I don't know if this is relevant or anything, but that ball in a urinal, so. Oh. In the urinal? You better go wash your hands. No, it like bounced through the urinal.
Oh, yeah, that would be very unsanitary.
Oh, don't worry.
Like, did someone use the bathroom? Did someone use the bathroom and then it bounced?
No, it just bounced.
Okay, so I need to go bleach my fingers.
Well, hand me my ball bag.
No, I'm not.
It's already getting fine, I'll grab it. That's funny. Just say that about everything. Just like, come check your math homework. This was in the year. Would you get for giving her my ball? I kind of thought you'd be grossed out.
Hand sanitizer's not enough. I'm gonna go boil my fingers now. Alright, so. I know. I'm glad I had some.
She just starts. It just kind of smells fun.
Oh. Okay, so. Now I can't focus. Let's look at.
You could always go grab sandpaper and just sand your skin off. Really do that. Grow new skin and it won't be.
Alright, so I'm gonna have to like go wash my hands and then Clorox everything I've touched.
Just about every single senior day. Whenever we eraser burn back in like 8th grade. I could sand it like every day.
Alright, so what's the next thing?
But then you get.
She always tried to hide. Don't make fun of each other. The faculty thing. Have you ever seen those like really big?
Alright, so looking at A through F, did you guys want to practice a cube, the sum or difference of two cubes, or one like B where we have a difference of two perfect squares?
Yeah, do B or D.
Okay. So B, we have the sum or the difference of two squares.
I bet the class is gonna put it out.
Alright, so looking at B, we have g of x equals x to the fourth minus 16.
So how does this work? Because on that one it says like a squared, a cubed.
Okay, so this one doesn't, we're not gonna use that. But if you remember from algebra and geometry that we had the difference of two squares. Okay, I can remind you. All right, let's just kind of do this old-fashioned way. So what's our middle term? Our middle term is 0, right? So let's just pretend instead of a fourth, it's a square. We have 0x minus 16. So we need two numbers that when we multiply them together, we get negative 16. Same two numbers, when we add them together, we get 0.
4 and
4 and negative 4. Alright, so when we have the difference of two perfect squares, we can square root the first term and we can square root the second term. And the square root of our a term is going to be the first thing in our parentheses, and the square root of the second term is going to be the second number, but they're going to have opposite signs, and that enables when we go through and do the addition for the FOIL or box method, our middle term cancels out. So if you could square root both the first and the second term, so the square root of x to the fourth is x squared, and the square root of 16 is 4. So we're going to have our two parentheses. We're going to put the square root of the first term in the first spot, and the square root of the second term in the second spot, and they're going to have opposite signs. Alright, so let me make up another one for you.
so
That's it. So instead of that one, let's do 4x squared minus 25. Alright, so we know we're gonna have two parentheses. We can square root our first term, right? So it's 2x. And then 5. So if we multiply this out, 2x times 2x gives us 4x squared. 2x times negative 5 gives us negative 10x. And 5 times 2x gives us positive 10x. Those cancel. And then 5 times negative 5 gives us negative 25. So now we just need to set each of these parentheses equal to 0 to find our root. Since this is a square, how many roots do we have? So we have negative 5 over 2 and then positive 5 over 2. And so those are our two roots. So the original one was x to the fourth, so how many zeros would that have? 4. What about, go ahead. Well, for the sum, which of these would be a sum of two cubes? A. And this one is sum or difference, and what about this one? Sum.
So it has more than a cube. You can't use that.
Right. If you had this would have to be a multiple of 3. So if you had x to the 6th plus 27. So can we cube root x to the 6th? Because we have, if we we have two groups of 3 in here. So we can have, so the cube root of x is 6 would be x squared. So for this one, our a term is x squared, and our b term is, so it's the cube root of 27.
I was about to say
I know, I was like,
So then our a value we put in x squared, and our b value we put in 3. So pretty much, since the cube root needs to be in groups of 3s, as long as it's a multiple of 3, it'll work. Your exponent has to be a multiple of 3. All right. So in our remaining time, your homework is going to be the check your understanding box on page 272, so 1 through 6. And then I'll give you some more practice. So just kind of identifying number 1. So looking at that, what kind of approach would you take to the factoring of it? What we just did. So here, this is a perfect square, right? And then 81 is a perfect square, so we have the difference of perfect squares. So you can use that route. Number 2, what are we looking at there? Yep, so we're looking at the sum of 2 cubes. What about in 3? Can you take out a greatest common factor? Yep, so you can take out an x squared and solve it that way. Number 4, you have 4 terms, so what's our approach? Factor by grouping. And then these two are kind of talking about the process. So
Can you scroll back up?